I would like to introduce our next speaker who came from Barcelona, Spain, but originally he's from next door, from Serbia. He's been various times on the craft stage, and he will be Viktor Farcic. He's a developer advocate at Upbound. He's also a member of Google Developer Experts, CDF Ambassadors, and Docker Captains groups, and also a published author. So please welcome on stage with a huge applause, Viktor Farcic with How to Build Your Own Heroku in 2022. Viktor, the stage is yours.
Thank you. Okay, that's me. So, is everybody familiar with Heroku? Are you all just finished university, right? Okay, so Heroku was a big thing 5-10 years ago, right? It helped a lot by providing some form of opinionated way to run your applications, right? You could, back in the days, you could just say, hey, here's my repository, run my application, and forget about it, right? Ultimately, it failed, so don't use it. But it became a golden standard of how we think about platforms in general, right? So, where is this? Why doesn't... This is me, depressed. Anyways, you already saw the intro, so I'm not going to go through what I am, who I am, and stuff like that. Instead, I'm going to jump straight into what I want to talk about today. And I'm going to start with DevOps, right? DevOps is something that everybody today is familiar with, and most of the people misunderstood, but that would be a separate subject. So, when I say DevOps, oh, there we are. When I say DevOps, most people associate DevOps with things like, hey, DevOps is all about containers, it's about Kubernetes, it is about cloud, it is about continuous integration, continuous delivery, Gitops, monitoring, logging, troubleshooting, infrastructure as code, security, service mesh, and so on and so forth, right? Most people associate DevOps with the tools that they use, and most people who are somehow in DevOps area are operations, sysadmins, people who like playing with tools. Now, in reality, none of those things really is directly related with DevOps. Those are just operations tools. And I'm using operations here in a very broad sense of words. It could be anything. It could be security, sysadmin, SRE, whatever you want, right? All those are ops tools that most of the people who are not specialized in them do not understand because they're too complex, or what they do is too complex, right? Now, from the developer perspective, what developers really want to do is not really play with your Kubernetes cluster and spend 7 years trying to learn 700 and something services in AWS and so on and so forth. And whenever we try to push those tools into developers, that always ended up in disaster, at least whenever I was involved in some such projects. And the reason is very simple, it's too complicated, devs cannot use those things. What DevOps really is about enabling developers to be self-sufficient. Because what we don't want to do anymore is wait for Jira tickets or emails or Slack messages with questions like, hey, I have a new application, I would like you to deploy it to production, or hey, I need a cluster, I need a database, I need whatever that something is. And DevOps is all about really making developers self-sufficient. It is about shifting left. I'm not sure whether everybody is familiar with the term, but think of it as having a line. This is a process, this is where the idea starts, and this is production. Typically, operations is somewhere on the right side. Those are the people who operate systems, those are the people who make sure that something is running, and so on and so forth. What we're trying to do, most of us, is to shift left, meaning that we want to shift the tasks that were done in the latter part of the process to the left, to developers, and enable them to be self-sufficient. And that's a pattern that you can see in almost every successful company today. If you go to Google, Netflix, small startups, you name it, they're all focused on how to enable developers to be self-sufficient, how to enable developers to be able to do things without waiting for you to do things for them. The one thing that was very popular in last couple of years, that's the attitude of shifting left by saying, now you do it, right? The same way as how it was extremely popular like 10 years ago to be full stack developers or developer, until everybody realized that one cannot be full stack developer successfully because that's simply overwhelming. There are too many things to know about being full stack developer. The same we are trying to, many companies are trying with DevOps, shifting left saying, here's the AWS account, use it, here's Kubernetes cluster, do something. Whether you know how to do it or not, that's up to you. In reality, where we are right now, where most of the companies are right now, or trying to be, is about creating services that allow operations to enable developers to be alone, to be self-sufficient, to not depend on them. And those efforts today are usually summarized or called as internal developer platform, right? Almost every company I work with is in one way or another focused right now on creating a platform for the organization, the platform that will enable everybody to do everything without really waiting for anything. It's internal, meaning for internal usage. That's not a platform that you get. You cannot buy something like that. Actually, I will discuss that later. It's about developers and so on and so forth. So what is IDP, or Internal Developer Platform? It is a layer on top of whatever you're using today, right? Whatever you're using, you need to simplify that something so that the knowledge that you have, you do not expect others to have. Others should go easy. It's about shifting left, and it is the true calling, the true job of successful SREs, operations, DevOps, right? Creating self-services. Now, the reason why, or the question, why do we want self-service? And the answer is relatively simple. If you create services that others consume, then you yourself can get free time, availability to do things that matter. Because you creating a cluster for somebody is a waste of time, complete waste of time. You creating a database or anything else is a waste of your valuable time. You can automate that, you can expose it as a service, you can have your customers, and customers are other people in your company. Then you can do what matters. And the reason why we want self-services, and there's a bunch of data to back that up. The first stop is usually DORA metrics. And there is a proof that says that teams that have self-services, teams that self-serve themselves instead of waiting for people in other departments, have higher productivity than other teams, have lower lean time, deploy to production much faster than others, are faster to repair stuff, have lower failure rate, and so on and so forth. Now, what self-service really means, theoretically, it could be in everything, right? Anything you do can be a self-service. But there are some focus areas, some main areas that most of us are focusing today. And that can be summarized in 4 different types of actions of areas. First of all, we need to enable people to change the desired state. That's where the desired state is extremely important, because we cannot really influence in complex systems what the actual state is directly. The only thing we can do successfully, especially at scale, is to express our desires and let the system figure out how to do that something, whatever that something is. We need to perform some actions, like testing, building, whatever those actions are. They're separate from defining the desired state. We need a mechanism that will converge the desired state. When I say desired state, think of YAML, HCL, JSON, Go, whatever you're using in Git. We need a system that will make sure that whatever is specified is actually what is running. And not what is running once, but what is running all the time, absolutely all the time. And finally, we need the capability to observe what's going on, because things go wrong every once in a while. So, go. If we would start building such a system today, if we would try to build an internal developer platform today, we would probably do something like this. It would almost make no sense to make something different. We have the actual state over there. Those are your servers, those are your clusters, those are your databases, and they're running somewhere. They're running in AWS, in Azure, in Datadog. You might have metrics in Splunk, logging, whatever you're doing. In those providers, you have infrastructure, servers, cluster databases, and on top of that infrastructure, you have applications. Those applications could be your applications, it could be third-party applications, it could be what you develop, it could be what somebody else develops. Now, the question really is, how do we get this thing on the right side? How does that become a thing? And today, most of us are in agreement that to get to the actual state, we need to define the desired state. That's your Git repositories, right? Nobody today, hopefully, is SSHing into a cluster or executing kubectl commands or going to AWS console and clicking buttons, right? We are storing the desired state, what we want, in a Git repository. That's your code, that's your build scripts, that's your YAMLs, and so on and so forth. And then we need to figure out how are we going to make sure that the things that we want are the things that are, really. And that's where Kubernetes comes into play. Kubernetes is a misunderstood thing, and many people understand and think that Kubernetes is all about containers running in your cluster, which is a completely wrong idea or wrong assumption of what Kubernetes is. Kubernetes, realistically, containers is just one fraction of what Kubernetes does. What it really, really does is that it gives us an API that we can use to control something or to query something. And more importantly, it gives us CRDs. CRDs are short for custom resource definitions. Nobody's supposed to use Kubernetes as out of the box. Nobody's supposed to just install Kubernetes and say, now I use it. We are all supposed to extend Kubernetes through custom resource definitions to get what we want. And those custom resource definitions are either third-party, something like if you install Argo CD, or if you install Flux, if you install a database from a third party, you will get CRDs. More importantly, we are building our own CRDs. This is where your operational knowledge becomes reality, because together with custom resource definitions, we have operators, we have control loops, and so on and so forth. That's how we define two things. First of all, what will be the interface that somebody will use when that somebody wants to do something? Manage a cluster, deploy a backend application, whatever that something is. And second, that's where your knowledge, the things that 20 years ago we were putting in Word documents, that's where your knowledge becomes code, because you're creating an operator that understands that whenever somebody says, I want this, you will pick that up and do whichever operations you need to do. It's not about containers. And if we agree that Kubernetes is the one that is going to monitor Git repository all the time, and through custom resource definitions, make sure that everything you have, absolutely everything, is always running, then we have a system that will propagate what we want to what it is. But 95% of the people cannot understand this. 95% of the people did not spend 5 years learning Kubernetes, right? They're developers writing Node.js code or whatever they're doing. That's why we, and when I say we, industry is focused now on the top part that says IDP. And to have IDP on internal developer platform, there are a couple of things that are extremely important. And that's why Kubernetes is so important. First of all, you need to have an API that you can use so that when you build a web user interface or CLI or extension for Visual Studio Code or whatever the people in your company are using, you need to be able to communicate with some API that will make sure that whatever is there, why is this turning off? Whatever is there is what should be. So we're building those layers right now, most of us, that are enabling developers through user interfaces, whatever those user interfaces are, And those user interfaces are either observing the state, never changing the state, or changing what is in Git, right? And when I say user interface, even Git CLI is a user interface in some form or way. Kubernetes reading what is in Git and making sure that two things are happening, and I forgot to talk about that. We have pipelines, Gitops, infrastructure, RBAC, those are all the tools that you love. But instead of using those tools directly, you're using them through Kubernetes for a simple reason, because we can extend it. And then the only thing missing really is for somebody to create custom resources and use it. So, the tools, if you would like to build something like this so that everybody can use our system and nobody needs to open Jira ticket, we need to talk about tools. And there are a couple of areas that are extremely important. First of all, how do we define applications and infrastructure? And the answer I already gave, that's Kubernetes custom resource definitions. That's what it is designed for. We need to talk about pipelines. Actually, pipelines are not that important in this story, because whatever you're using today should be okay as long as that something is not Jenkins. I've worked for Jenkins for many, many years. We need to figure out how do we synchronize those states. There are only 3 tools in the market that are worth talking about. You're either using Argo CD, or you're using Flux, or you're using Fleet and wondering why did you ever make that decision. We need to figure out how do we orchestrate the infrastructure. How do we extend Kubernetes to do what we need it to do? And the commonly used tools right now on the market are either Crossplane. I work for Crossplane, I'm biased. ACK, for example, or any infrastructure as code tool that has Kubernetes operators, right? Which is most of the infrastructure as code tools today. We need to figure out how are we going to orchestrate applications, because if you're running things in AWS, or if you're running things in Kubernetes, or wherever you're running, it's a real nightmare. Let's take Kubernetes as an example. What is an application in Kubernetes? An application in Kubernetes is a deployment with a service, with ingress, with virtual services, with storage, and so on and so forth, right? Too complicated for a developer to understand, to use. That's, again, going back to custom resource definitions. That's why we are using tools like Open Application Model. I don't know if anybody got used to it. Kubevela, Crossplane as well, and so on and so forth. Hopefully my demo works today. Let me see. If it doesn't, then I'm in deep trouble. Then we need to talk about RBAC. How do we restrict access? You know, not everybody can go to production. Not everybody can do whatever the heck they want. And the answer is very, very simple. It's Git. Because if everything you do always ends up being pushed to Git, then nobody needs access to servers. Nobody needs access to cluster. Nobody needs access to AWS, except in case of a disaster. So we have authentication, authorization, RBAC, based on Git, and actual state is always in Kubernetes. Then we have the process, right? How does that all work? How does that all look like from a human perspective, right? That's a human over there. You're pushing stuff to Git. I don't expect any developer to do anything except write code and push to Git. Any other expectation is a waste of time. We push some stuff to Git, and then when we push things to Git, 2 things are happening. Either we did something that requires one-shot operation, meaning we need to execute something that should happen once and only once. That's running tests, creating building images, building binaries, whatever you're doing. That's what we're doing with pipelines. And then we have a different type of operation that is ensuring that the state defined in Git is always present. That's not happening once, that is happening literally all the time. That's a loop, constantly. That's what we call Gitops today. And that's what is synchronizing your repositories with Kubernetes, and then Kubernetes, because those tools, Gitops tools like Flux, Argo CD, and Fleet, they do not have a capability to understand what you really want. The only thing that they're capable of is literally doing the same thing over and over again, and that same thing is synchronizing what you want with what is defined in Kubernetes through your custom resources, and then Kubernetes is making sure that whatever you have is running, and is running always. So, the whole goal is to have a system that is tailor-made for developers. You cannot buy it off the shelf. You cannot go to a vendor and say, give me a platform, simply because they do not know what you need. Then you end up going to Heroku. Now, I'm realizing that my time is running out and that I will not have time for all the slides, so I will try instead to go quickly to a demo and show how part of that works. And here we are. Here's my demo. So what I did before I came to the stage, actually last night, after quite a lot of beers, I created a cluster, I installed Argo CD in that cluster, and I pushed some files over there. The reason why I did that in advance and not right now is because it takes like 20, 30 minutes for AWS to wake up and do the stuff. So I have a system operational. I have whatever I described over there is running. And now I can show you how that looks like from the user perspective, from a developer perspective. Just see, okay. Okay, so let's say that you want to create a cluster, right? How would you do that? What I'm going to do, I'm going to create a completely new cluster right now, and I'm going to do that by copying a file to a directory, right? And then I'm going to do git add, git commit, something, git push. Cool. Now, I'm checking the time. Now, while this is happening, right, all I did so far is push something to Git, and I'm going to show you what that something is. The important thing here is that I will not talk to my cluster in any form of way except to show you what's happening. I will not change the state in any form of way, right? So what did I do? I did something like this. I defined this file. Can you see this? Is this big enough? Hopefully. Okay. So I said, hey, I would like to have something called composite cluster. Now, what is composite cluster? That depends on operator, on SRE, on person who actually chose to create a service for you, right? You can check the documentation. You can see what it is yourself. What does matter is that I have no idea how to create the VPCs and networking and ingresses and whatever I need for a cluster, but I do know what I want. And what I want in this example is to say, hey, I'm going to call this cluster like this, whatever is the name. I'm going to say that I want that cluster to run in Civo, which is just one of the, you know Civo? No? Nobody? Okay, you're spending too much money then on AWS. Anyway, it's like AWS-like service, and I'm saying I want small servers. I do not know what small is. I just know that I wanted them to be small, and I want to have one node in my cluster. One server, that's enough, right? Now you can say, this is too simple, so let's do something more complicated. Because Civo, to create a Kubernetes cluster in Civo, you literally just need to go to Civo UI and say, I want a cluster. But if I would like to create a cluster, let's say, in AWS, what would I need to do? There we are. If I would like to create a cluster in AWS, I would need to create the in-case cluster. I would need to create a node group. I would need to create subnets, VPCs, internet gateway, roles, role attachments. I don't know, I probably forgot 10 other services that I need to do. Or I can say that from developer perspective, creating a cluster is exactly the same in AWS as in Civo. All you have to do is exactly the same. I want composite cluster. I'm going to call it something else. AT, MKS, and I'm going to have the same parameters over there. I mean, not the same. Values are different. This time I'm saying that I want medium size of nodes and I want 3 nodes. But from developer perspective, it's exactly the same. From what is happening in the background is completely different. And to make things more interesting, I defined here something called Gitops, right? And that's for all the people in my company that want to have a cluster that is already hooked into some Gitops tool without knowing how to install it, without knowing what to do and how to do it. And all I have to do is to create a new resource definition in Kubernetes called Gitops. I have parameters. The only parameter that matters is the bottom one, where I'm saying, hey, the only thing that I care about is for that tool to be Argo CD. You can see composition ref name, Gitops Argo CD. And I wanted to monitor this repository over there. And what I should do now, if I would copy this file into a specific directory and push it to Git, then Argo CD or Flux or whatever I'm using to synchronize Git repository with my management cluster will synchronize it and things will happen. Now, I'm not going to do that right now because I did it last night. The first cluster that I showed you, that I did in front of you because it takes 2 minutes in Civo, but AWS takes half an hour. So I did it in advance, but the result would be exactly the same. So what happened when I applied those 3 resources? 2 resources that define a cluster, one in Civo, one in AWS, and 1 resource that defines that I want Gitops, something, right? The result of that something is this. It will take a couple of seconds, 5 seconds to figure it out. But yeah, the result of that simplified complexity is that I, as the author of those services, I, as administrator or sysadmin or SRE or DevOps, whatever I am, I defined whenever somebody says that they want a cluster in AWS, I should create those roles. I should create those policy attachments. That cluster should be production ready, meaning that certain things need to be installed in that cluster. It's not only having a cluster, it's about, and right now it is actually working. Those are from last night, those are happening right now. And I should install some applications over there, and I should create a node group, I should create a cluster, I should create Internet Gateway, VPC, route table, security group, subnets, and all this until the bottom is AWS related because AWS is complex, and this guy here is the simpler version which is in Civo. This guy over here at the top, right? So, the complexity still exists. It did not disappear, but it is hidden from everybody else. And it is not hidden in terms that some vendor chose how to hide it. I chose what it is. And I can prove it to you that if I get a secret here that allows me to connect to that cluster, and if I retrieve the nodes of my cluster, maybe, if it works, there we go. That's my cluster. That's one of the 2 clusters I created. And the only thing left really is to explain how that magic works. But by the way, I didn't mention, because I'm bad at marketing, all this is Crossplane and Argo CD. So, how do you design all those things? And it's relatively straightforward. You need 2 things. You need a definition. You need to define what something is, whatever something is, and you need to define how that something will behave. And the first one is the definition. And here I'm saying, hey, you know what? In this cluster, I would like to have a new schema, new custom resource definition, and it will be based on Open API schema, and it will have some properties like ID. It will have some parameters like version, node size, minimum number of nodes, all the things that you saw in a YAML. I'm designing the interface. I'm designing the service that my people will use. And then I need to design an implementation. And that implementation, this is just too much, let's do more. That implementation is the complex part, right? That's the part that is your job, but you don't want to force everybody else to do it, right? This is where I'm designing a cluster and this is when I'm putting some fields, and this is later on creating a node group, and IAM roles, and so on and so forth, right? This is, if you're used to Prometheus, if you're used to Terraform, Ansible, Pulumi, this is the same thing, right? Except the major difference is that this time I'm not designing something that I will use, I'm designing something that others will be using. And then if I have additional benefits, I assume that most of you are using Kubernetes today. You have all the benefits of Kubernetes, like control loops, drift detection, reconciliation. It's not something that is happening. When you execute Terraform apply, you're choosing to do something yourself. When you're using Kubernetes, you're delegating to Kubernetes the work to make sure that that something is happening all the time and not only when you execute it. And I'm now really surprised that it all worked. I think that I have some time for questions, right? Or can I continue? He's not paying attention. I'm just checking. So, how much time do I have? Nobody knows. Okay, so let's say that I would like to, what else can I show you? Let's say that I would like to deploy an application to production. And let's say that that application should be a backend application, it should have a database, right? What would you need to do? You would need to create a deployment service, Ingress, virtual service, and then for the database, you would probably, let's say that you choose RDS in AWS, you would need to create RDS, subnets, and so on and so forth, right? A bunch of things. Or we can design yet another service for our developers and say, hey, you don't need to worry about those things. I actually encapsulated everything into something called APP, short for application. You can choose what is the type of application. And in this case, I'm choosing APP backend DB. And you can specify some parameters. All the things that you care about are here because we spoke, we agreed that that's what you need, and all the complexity is hidden. Same thing for database. You can choose database in AWS and PostgreSDB. It could be AWS MySQL, it could be on-prem, it could be Azure. It all depends on the implementations that you created, right? It's a service. And then, if I would like to have that as a developer, all I have to do is define this, like 20, 30 lines of YAML, equivalent to 1,000, push it to this directory, do git add, commit, apply, push it to Git itself, and that's about it. What will happen is that soon, actually I can show you here soon, here we go, soon, Argo CD, not this one actually, that's wrong. Argo CD that is in that newly created cluster. We'll pick it up because I already said when I created my cluster, I said monitor this directory, this directory in this Git repository. It will pick it up, it will figure out, it will propagate it to the management cluster, and Crossplane, Kubernetes, and so on and so forth will figure out how to create all the resources that are required from that. And at one moment, I think that synchronization is happening every 3 minutes. A minute or two from now, when I execute this command again, you will see that the application, the database, the process of creating those things started. And now I have time for questions, or no time for questions. No time for questions.
There is. So first, a big applause for Viktor, please. You said you like beer, but actually it's wine from the organizers.
I'll take it. Yeah, I'll take it.
And now, if you can switch on the screen with Slido, so you can ask questions, but via Slido, please. So there's already one question on top, but I will start with what is different between the Crossplane and other tools which are similar? So what is the main difference?
Yeah. So in the past, the tools that we use, like Terraform, Pulumi, Ansible, and so on and so forth, they're one-shot executions. They're CLI tools. You define something which is absolutely great. You execute a command, and then something happens. If something happens to that live system at runtime, then you will have no idea, because the command that you just executed finished running, and it will not run until the next time you execute it again, which could be an hour later or a month later or whenever, right? Kubernetes itself, Crossplane included, is different. First, it gives you an API. You don't have an API with any of the other tools from the past. It gives you a control loop, meaning that it is doing the job for you. It is constantly monitoring the state of everything and correcting it depending on what happens. And then there are compositions, the ability of Kubernetes to create custom resources that extend what you can do.
Thanks for your answer. So we have a few minutes for questions, and as far as I see, there's already one. Isn't Terraform ready to use IDP? What's your take on it?
So, sorry, isn't Terraform ready to use IDP? No, really, no, absolutely not. Because there is no IP. First of all, there is no API. I do not understand how can anybody design some kind of interface, doesn't matter what type of interface is, without API. It's just silly. You can create modules in Terraform, but then what do you do with those modules? No.
How about Jenkins X?
Oh, I was a product manager on Jenkins X. And it's a disaster. Now, you can figure out whether it's a disaster because I was product manager on Jenkins X or for other reasons, but we had great ideas for Jenkins X. We failed to execute. We failed to make it stable, to make it work. And then most of us left the project, and now nobody's maintaining it. So unless you want to become a core maintainer for Jenkins X, don't.
So you do not recommend Jenkins X this way?
Not today. No, not at all. No.
Okay.
Don't. Please don't.
Let's see, as a production owner, how do you deal with giving devs a fast track to change, break things, and still sleep over the sound of pager duty?
So, no, it doesn't work like that. You cannot you cannot empower people to do things without empowering them to deal with consequences. That's just silly. So, I would never allow somebody to deploy a new release to production if that somebody is not responsible to receive a pager duty call when something goes wrong. That's not how things work. If you want to empower people to be self-sufficient, if you want to empower people to deploy something to production, to create the database themselves, then they need to be woken up in the middle of the night and not somebody else. That's how it works. That's the whole idea about being self-sufficient. You get power with responsibility, not one without the other. Now, of course, there are people who, outside of those groups, but that should be woken up, what did it say, overnight. But those are people that manage the system as a whole, not the part that we empowered others to use. And also, by the way, if you have that separation, kind of like you develop code, but I receive pager duty, how do I know what you did? Even if I deploy your stuff, how do I know what you put in that application? I never understood that concept. I never understood how can I not write the code of the application but be responsible for that application in production? To me, that is completely bonkers. I never understood how that worked. I'm sorry if I'm offending anybody.
I think you're not offending anyone. Okay, do we have any more questions, or that's all? So, looking to the technicians, there's no more questions. So officially, I can tell that thank you very much for being here with Craft. Okay, there's one more question.
Yeah. Do you think Git providers are ready for Gitops? I'm not sure what Git providers are.
GitHub providers, I guess.
GitHub, I don't know what GitHub providers are either.
So who is anonymous in the room? Can you
is anybody here?
Can you
don't be a coward. Stand up.
Questions about GitHub, and when we're trying to integrate, we shift access control to Git with Gitops, and that therefore the access control relies on GitHub. Who can do what?
Yeah.
And I feel that that's not enough provided by them.
So, yeah, so if I understood it right, the question is whether access control in GitHub is sufficient. It depends how you organize stuff. If you have if you have, let's say, microservices, many small repositories focused on something, I think it works well because either you can push to the mainline or you can create a pull request, or you can do neither of the two things, right? Pull request is a way to enforce that somebody needs to review before pushing to the mainline, merging to the mainline, or if you're funky, you have permissions to push directly to the mainline. But I think that that's enough. I think that people complicate things too much. You know, kind of typical big organization, then we end up with processes that nobody understands. But either you need approval from somebody, that's a pull request, or you don't need approval, and then you can push directly to the mainline. I don't see a third option. And actually, there is a third option. You cannot see what's in that repository. But companies that deny people even to see read-only into repositories are just bound to fail. Just quit. Change the company.
Thanks.
Yeah, so yes, I think
Nothing to
it
add.
is.